Okay, good evening, everyone. Hope you all are doing great. Okay, may I know what we discussed yesterday? Till then, I will share the screen. Yeah. May you please confirm what we discussed yesterday? Doubly linked list. Great. So, which operation we conducted in it? I guess insertion. Insertion in a doubly linked list, right? Okay, fine. So, let us quickly recap yesterday's session. So, it was linked list that we started early on. Then we started with different operations in the linked list. Be it insertion, be it deletion. Insertion at the beginning, insertion at any position, insertion at the end. Similarly, we did deletion in a singly linked list, right? Deletion from the end, deletion in the middle, and deletion from the front. So that we did yesterday, right? You can revise the concept, and then we explained something about doubly linked list. And in DLLs, we call them as DLLs, doubly linked list, right? In data structures. There is one more term, DLL in computer science. May I know what is that? DLL. Most of the time is used apart from this doubly linked list. DLL is also used in CS. May I know the full form of that DLL? Most of the times you will come across DLL in computer science. What is that DLL? May I know? Am I audible? Yeah, it is dynamic link library. So DLL is also dynamic link. It is this is the most famous term in computer science, DLL. Also, these doubly linked list, they are also called as DLLs in short form, right? Okay, so today we will see another operation in these DLLs, these doubly linked lists, that is deletion operation. Right, simple. Deletion is removing a node from the linked list. Simple. See, we have got this linked list. Let me set the settings on screen, then it becomes easy. I have got this linked list. Right? This is the first node, second node, and third node. I just want to remove the node at the beginning, at the start. So, see, this I called as the first node. Node first, the previous of the first node, it is pointing to null. And next of the node 1 is pointing to 2. Similarly, previous of node 2 is pointing to node 1. And next of node 2 is pointing to node 3. Then node 3, previous of node 3 points to node 2. And next of node 3 is pointing to null. So whenever a node is pointing to null, we say it is the last node. Isn't it? That we discussed yesterday also, and today I have shown it. So whenever a node is pointing to null, we say next of node, not previous. If it is previous of the node is pointing to null, it means that is the first node then. Like suppose over here, if previous of node, any node is 1, here previous of 1 is null. So it means it is the first node. So when the next of any node is pointing to null, we say it is the last node. So here we have to check that condition as well. So if head is equivalent to null, so what does this mean? Whenever this head is pointing to null, So it means, can anyone? I have only head, and this head is pointing to null. So what does this designate? Yeah, simple. The list is empty. So whenever head is pointing to null, for example, this was head and it was pointing to null. So we say the list is empty. We can't delete any node, right? So this is the first condition. Now, otherwise, what we'll do? If this is not the condition, head is not the null. So it means there are some nodes in the list, right? This is not true, right? So we'll simply go to here. For that purpose, we are just saying that there are some nodes in the list. If head is not pointing to the null, either one node, two node, or any number of nodes. But the condition head is not equal to null pertains that the list is not empty, right? That is fine. Now, otherwise, we have to set head is equivalent to head dot next. So what does this mean? See, initially head was pointing to this node, right? Now I have to free this node. I have to remove this node. So it means I have to the links which this node is having to this node. I have to remove those links. So simply I will say this head dot next, it will become a new head. So head dot next would be like this. It will pertain to here. And we have to also check if head is not equal to null. So what does this mean if head is not equal to null? Can anyone see here? Head was null, first node. Head not equal to null, so it is not the first node. So at that time, I will simply set head dot previous is equal to null. So whosoever has become a new head, set the previous of that node equal to null. So that will become the what? First node of the list. So the next node, that is now the node 2. Its previous will point to null. So it simply means it has become now the first node. Right? It is simple, I guess. Is it fine? Yes. Okay, let me explain it a bit further. See, first of all, we have to check if the list is empty. Right? For that purpose, what we are doing? We are simply checking if the list is empty means if the head is equivalent to null. So we are checking it. For what purpose we are checking it? We are checking it in order to check whether the list is empty or not. So we all know that this head variable, it points to the first node of the list always. Like last of null is equal to null, last of next is equal to null, we mean that is the last node. And we mean if head is equivalent to null, it means list is empty because head variable always points to the first node of the list. And if head is equal to none, then there are no nodes in the list at all. And we know the list is empty. When the list is empty, then there is nothing to delete. So we'll stop all the operations over here. This is simply, see why we are doing all things like this. It is simply a safety check. Like suppose you are doing an operation on a linked list, you want to delete a node in a linked list. But what if there is no node at all? So that is why we are just doing a safety check to avoid errors like trying to delete a node that does not exist in the linked list. Right? Then we'll move to this step. Step 3. Right? If the list is not empty, right? The current head. See here, I am just writing head dot next is head is equivalent to head dot next. So with this step, I am simply moving head to the next node. So when head this list is not empty, the current head points to the first node, which we want to what? Which we want to delete, isn't it? Are you getting or not? If list is not empty, the current head pointing to the first node which you want to delete. And by assigning this head is equivalent to head dot next, we are actually making the second node, if that exists, the first node of the list. It is simple. So by doing like this, head is equivalent to head dot next. So we are simply making this second node as the first node of the list. Right? So this will effectively remove the reference of the original first node. Means whatever was the reference to the original first node, that will be removed. So this list will no longer, this will no longer remain part of the list. And this node, first one, it will eventually be removed by, we know that this Java, it has actually got a garbage collector. Since nothing, it points to nothing now, right? Nothing points to this node now anymore. So it is now kind of a garbage. When it has been free, nothing is pointing to this node. So what will happen? It is a garbage. So by the Java's garbage collector, it will be eventually be removed by this Java's garbage collector. Right? Then what we'll do? We have a step 4. If head not equal to null. So this simply means we will update the previous pointer of new head, because see, this node has been removed. Now I have to update the pointer of this, the node which has now become the first node. I have to update its pointer. So after removing the head to the second node, after moving head to the second node, now we need to update the previous pointer of the second node. And we know this second node, it is now the first node. So it is previous must point to what? It is previous must point to null, to indicate that there is no node existing before this node. Two things are there. We have freed this node and it has been eventually removed by the Java's garbage collector. Now this node, second, it is now the first node. So this first node, in order to make it first node, it is previous must point to null. So with that, we indicate that there is no node existing before it. When this node is pointing to, when the previous of this node is pointing to null. So if we don't do this, if we do not write like this, previous head dot previous not equal to null. So what will happen? Can anyone tell me? It will still incorrectly point back to the first node, old first node, which is no longer in the list, but still it will point to that if you will not write head dot previous equal to null. So with the help of this step, head dot previous equal to null, it will do what? It will simply fixes this. It will fix the backward link. It will remove this backward link to keep our doubly linked list consistent. Otherwise, if we will not do this step, if we will not write head dot next previous equal to null, it will still point to the previous node that no longer exists in the list. So for that purpose, we are doing like that. So this is actually how we are doing this deletion when we have to remove the first node. I hope it is clear. Yes. Is it fine? Do tell me. If you have any questions, you can ask. Okay, is it fine? Don't write unnecessary messages over here. Just tell me if it is clear or not. ask these certificate regarding questions while we while we wind up the session. Do you have any queries apart from this? Please ask at the end of the session. Okay, so is it fine? Just tell me. Is deletion clear? Is it clear? Just type a message, yes or no. Then we will explain the program. Yes. Shall we proceed? Shall we proceed? Yes or no? Okay, so let us discuss this program. The program of doubly linked list. It is easy. You can run it, but the thing is, we should be able to explain it. See here. Let me try to explain it. So initially we are creating a node. We have done it previously. Like in a singly linked list, we only have their data and we have node of next, not this previous. So here what we have? We have three things, node of next and node of previous. So we have created a node. Then there is a constructor with the parameter as data. Then we are giving this dot data in the form of data, whatever data we have or whatever data we want to delete. Okay, node dot head. We have to check delete this. Now we'll do deletion from the beginning. So first condition is simply if head is equivalent to null. See, if you try to explain this program now, if you try to learn this program, it is very easy. You can write it within no time. The only thing is, if you have a good understanding of how do we delete a node in a doubly linked list. Simple. The very first condition is if head is equal to null. So what does this mean? It simply means list is empty, nothing to delete. That's it. Then we write head is equivalent to head dot next. If head not equal to null, so what does this mean? See, we are creating a variable head and we are putting in that head dot next. If head not equal to null, what does this mean? Simply we will set head dot previous is equivalent to null. So it means nothing is there. Now, if it is like this, head is equivalent to head dot next. If head not equal to null, head dot previous is equal to null. So we are just setting the things when head is equivalent to head dot next. So that node will be deleted from the beginning. See, add node at the end. If we have to add a node at the end, for that what we'll do, if head equal to null, head is equivalent to new node return. So here actually what we are doing, we are simply adding a new node, then printing the list. Let me run this program. I will check what will happen with it. Let us check what will happen. Let us check. I will copy this program. Okay, this is the output. See here, doubly linked list we have 10, 20, 30 because I am passing these values over here. 10, 20, 30 is there, right? Dynamic DLL dot append. I'm simply adding those lists. That is why I'm creating a node over here. This, adding a new node. So with the help of this, what I am doing, I am actually passing these elements to the linked list. Then node deleted from the beginning. Then after that, see, delete from beginning, DLL dot display. Delete from beginning is this one. This one. Right? If head is equal to null, system dot out dot print list is that we check it. Else simply write head dot next. If head not equal to null, head dot previous equal to null. That we explained. So this is how do we write a deletion code. Here we are actually adding a new node that we did yesterday. How do we add a new node to the linked list? Then we are printing the result, and simply this is adding and deleting new elements and the display. So this is actually what we are doing. See, it has actually initially deleted 10, 20, 30 is there. Then it has deleted 20, 30 is there. Then there is nothing in the list. So nothing in the list. So we can't delete anything. So this is actually how this program is working. Find this. It is simple program. Create an this node. Simple. Delete a node. Check the conditions. Add a node to the list. Print the results. And that's it. So this is how do we actually delete a node from the linked list. So this is the program. Now, we want to delete a node at the end of a doubly linked list. So it was deletion at the beginning. Now we want to delete at the end. Same here. The very first thing, if there is only one node or if there is no node in the list, what we have to do? We have to check this condition. If head is equal to null, what does this mean? Again, the list is empty, nothing to delete. In the last program and in the last algorithm that we check. Now, if head dot next is equal to null, this head dot next is equal to null. So what does this mean? Can anyone tell me? What does this mean if head dot next is equal to null? Yeah, tell me. Head dot next is equal to null. Yeah. It is the last node. Anything else? Head dot next is equal to null. Yes, it is the last node, but the answer is only half. It is not completely correct. Because we are at the very first step checking head dot next is equal to null. Yes, tell me, what does this signify? Head dot next is equal to null. Great, it is the first and the last node. See, you have written it is the last node, that is fine. But the thing is, it is also the first node because we are checking it at the very first step. So whenever we are writing head dot next is equal to null, it means there is only one node in the list. It is the first as well as the last node in the list. So in order to delete that node, this only node in the list, we simply set what? We simply set head is equal to null. So if it is the only list, by putting head is equal to null, it will empty the list. So it is simple. Just write head is equal to null, it will simply empty the list. So that's it. Yeah, we after this we can print the message that the list has now become empty. So this is if the list has only one node. Right now we traverse to other nodes of the list. If there are more than one nodes in the list, so we have to traverse till what? Till we will reach the last node, isn't it? So for that, what we'll do? We will traverse to second last node. Last node is fine, but we'll stop at second last node. Why? Because we will set the second last node is next equal to null. And this, yes, we have to only set that. Second last node is next is equal to null. Now, if the list has more than one nodes, we have to find the node just before the last node. That is it. Simple. If I have got 10 coaches, I just want to remove the last coach in a train. What I have to do? I have to reach the last but one, means second last node. So what I have to do? I have to set the next of second last node as null. Like suppose DMO, stop DMU in the train. So with that, what I will do? Last node will get deleted. So same here, I have to traverse till second last node, last but one, right? So for that, what we'll do, like previously, we use a temp variable, or I can say temporary pointer, starting at head, and we will keep moving temp forward, temp dot next, temp dot next, temp dot next, until temp dot next equal to null, right? So here, I have to start traversing till what? Temp dot next is equal to null. So it means we have to traverse until temp dot next is the last node. That is temp dot next, uska next is equal to null. So here, till here I have to traverse. Then I have to set temp dot next equal to null. Right? So with this, what I will do? I will simply keep moving forward. One coach, second coach, third coach. Temp is equal to temp dot next. Temp is equal to temp dot next. Second, third, fourth, till last node. Temp dot next is equal to null. So this means this temp dot next will become the last node. So temp is the second last node. When I say temp dot next is last node, what does that mean? That means temp is the second last node. If I will say ninth bookie ka next, it is DMU. So it means ninth is the second last before 10th. Are you getting it or not? Tell me yes or no. Yes, do confirm. Am I audible? I am waiting for your response. Is it clear? Okay, good. I will explain. This is the thing. If you are not getting the things, just type. I will explain. Okay. This is the algorithm, right? So I have to delete the node at the last of the list. So see, I will give an example. I have 10 coaches in a train, and I want to remove the last coach, 10th coach. So for that, initially I have to check if there is no coach in the list, that I have to check. So for that, what I will check? I have to check simply if this DMU is null. If head is null, means there is nothing, only DMU is there. DMU you can consider of as a head, right? And last DMU you can consider as null. So these are those DMUs, simple kind of boxes you can consider, having that joint that is connecting the trains, links I can say. So when I say head is null, means there is nothing attached to DMU. It means there is no coach attached to it, so the list is empty. Right? Now, if I will say head dot next is equivalent to null. So what does that mean? It means there is one coach and it is coach's next is null, means that coach is connected to another DMU null. So it means this is the only one coach in the train. So this is first and the last coach, right? Means there is only one coach. So I have to remove this coach. What I have to do? I have to again set head is equal to null, DMU is equal to null. Like DMU was on loan there, again I have to set DMU equal to null. So when I say DMU equal to null, the first coach gets removed. So the node, only node which was there, that gets removed. This is simple, right? Now after that, now there, like suppose there are 10 coaches. DMO is connected to first, first is connected to second, second to third, fourth, and so on, eighth to ninth, ninth to tenth, and tenth to again DMU null you can consider, last node. Now what I have to do? I have to traverse to what? To the second last node, right? So for that purpose, what I have to do? I have to check if the list has more than one node. That I am pretty sure now the list is having more than one node. So for that, what I will do? I will use a temporary pointer temp, and this temp will start at head, right? So we will keep moving this temp forward. Like initially it was temp, now temp dot next first node, temp dot next second node, temp dot next third node, ऐसे ऐसे करके temp dot eighth ninth node. Temp dot next means if next is eighth, temp dot next means ninth node, temp dot next it means last node. When temp dot next is equal to null, so what does this mean? This simply means we are reaching the ninth node. It is ninth dot next is equal to null, means this is the last node, right? Ninth dot next, that is 10. 10 dot next, that is null. So 10th is the 10th coach is the last node. So whenever I am writing, I am reaching temp dot next is equal to null. So this simply signifies that it is the last node of the list. So I have to stop over here. When I write temp dot next, see temp dot next, you know it is what? It is the any node. Like suppose I have to traverse still. When temp dot next is like suppose ninth. Ninth dot next is 10. When ninth dot next is equal to null, it means 10 is the last node. So I have to traverse till temp dot next. Fine. Then after that, what I have to do? Yes. So by this temp dot next is equal to null. This condition simply means that temp dot next is the last node. So temp is the second last node. When I say temp dot next is null, temp dot next is the last node, and temp is the second node. Again, I am repeating. See, simple. When I say, where is the pointer? Let me write it. When I say 8 dot next, it what which node it is? Ninth node. When I say 9 dot next, which node it is? It is 10th node, right? So when I say 9 dot next is equal to null. So what does this mean? This means 10th is the last node. So when I say temp dot next is last node, yani ki temp is like this, 9 dot next is temp. When I say it is last node, so what does this mean? This simply signify this temp, yani ki 9 is second last node. Hope it is clear. Yes or no? Again I am writing, like suppose 8 is temp, 8 dot next, it will signify ninth node, right? I am supposing it. Ninth coach dot next, which node it is? It is 10th coach. When I say 10 dot next is null, what does it mean? It means 10 is the last coach, isn't it? Yes or no? So when I say 9 dot next is null, what does this mean? This simply means 10 is last node again, isn't it? So I have said this as temp dot next ninth node, temp dot next. So when 9 is the 10 is the last node. What is temp? Temp dot next. Simply temp was here 9. Temp dot next is which node? Second last. So this is how do we check for the second last node. Is it fine now? Yes or no? Okay, then after that, we will simply remove the last node. So how do we remove the last node? How do we remove it now? Shall I clear the drawings? See, once we find this second last node, assigning temp dot next is equal to null. Yes. By assigning temp dot next equal to null, what does this mean? This simply means we are removing the last node, and you are now referring this 9 dot next as null. If I write like this, now I am writing 9 dot next. Temp is 9. 9 dot next is equal to null. So what does this mean? This simply means 9 becomes the last node. So when 9 becomes the last node, what happens to 10? 10 will get automatically removed. So once we find the second last node, we remove the last node by simply setting temp dot next equal to null. So by writing temp dot next equal to null, this will simply break the link between last node and the second last node that was initially there. So this will break that link to the last node, and effectively when the link gets broken, the node will get removed. It will simply, when you say 9 bookie ka jo link, ninth bookie is link, ninth bookie is joined to simply the null to the DMO. What does that mean? It means that the 10th coach gets removed because it is a doubly linked list. So the removed node is now unreachable. And again, I am just saying, whenever we are removing the node that is there without any kind of connection, any kind of links, so that gets cleaned up with the help of Java's garbage collector. Right. So with this, we are deleting a node from a doubly linked list when that node is at the last of the doubly linked list. We can write a program. I have already a program. Let me check for that as well. Oh, here it is. See here again, same procedure. Because the programs I have created, I have written him one like same. See, same in the previous class. I have created a node, previous, next, and data, then a constructor giving the data to it. Then I am simply deleting a node when if the list there is nothing to delete, checking that if head is equal to null, like in the previous case. Then I will check if there is only one node in the list, means if head dot next is pointing to null. So for that, we will set head is equal to null. So it will simply remove the first node. Then I will traverse to the second last node using a while loop. While temp, see here, I have set a temp node equal to head. Then I am checking temp dot next is not equal to null. So whenever it is not equal to null, so it means the node is not the second last node. When this temp dot next is equal to null, that I have shown pictorially with the help of example. When this is null, so it means it is the second last node. So when it is the second last node, I will simply remove the last node. How do I remove the last node? Set temp dot next is equal to null. So when I will say temp dot text equal to null, it will remove the last node. Then simply I will append the node. This is for adding the nodes in order to delete it later. So I will append, then I will display, and I will show the out. So this is how do we do the things. If I will run it, hope it is clear. Let me run this. See, this is initially this is the doubly linked list. That was there. That I have created by passing different arguments, different elements, nodes. So now delete the node from the end. 10, 20, 30 got deleted. Then again, I am deleting recursively. Not recursively, deleting in the second step as well. Then 20. So this also deleted. And finally, I am deleting the 10 and it is showing the list is empty. So this is how do we delete a node at the end of a doubly linked list. I guess it is clear. Yes, tell me. Any questions? You can check the program as well. It is very easy program. Only you have to keep track of this. Head is equal to null. Head dot next is equal to null. Uh, temp dot next is equal to null. Then simply write temp is equal to temp dot next. Right? So by writing temp is equal to temp dot next, we will simply remove the last node. Okay, just a quick confirmation. If it is fine, just a thumbs up or any kind of a message if you want anything, any questions. Yeah. Then we'll go to the other part of the course. We'll go to circular linked list now. Then after that, we'll complete queues, then stacks, then queues. Then we will go to the non-linear part of the these data structures, means trees and graphs. Then we will cover shortest path graphs, so the different graphs, shortest path algorithms, DFS, BFS, Dijkstra's algorithm, Floyd-Warshall algorithm. Also in trees, we will see, I guess if we get a time, we can explain spanning trees, Prim's algorithm, Kruskal algorithm. We can also discuss TSP, traveling salesman problem. So we'll be discussing all this. They are all important. See, this linked list is a bit, I can say this now, boring kind of a thing. But once you will get these, a grip of in these variables, temp dot next, head dot next, so it all becomes easy. The only thing is your concentration. How do you concentrate on these kind of things? Once you concentrate, you will get one linked list, you get clearly. All will become very easy. Okay. Shall we go to the next part of the course? So we have discussed it. Yeah. Now, after that, we have a circular linked list. Now, what is a circular linked list? Write down your definitions in the chat box. I will read those definitions. Circular linked list. Yeah. I am waiting for your responses. What is a circular linked list? Be quick with your answers. Yes. Last node list and point to the head node. Good. First node address is stored in the last node. Very nice. Great. Okay. Only these three circular list. So it means only these people are in the class. Last node pointing circular link list. I want answers from everyone who are in the class. What do you know about a circular link? But make sure you will answer it quickly within 2-3 seconds. You will not waste much time. Last node back the forming a circle instead of ending with a null pointer. Good. Good, good. Last node points to the first node. Okay, good to see your answers. Great. Now at the same time, I want you to give me the practical application of circular linked list, where you have found this circular linked list useful in computer science or in day-to-day life. Yes. Last node pointing to first forming a loop. Yes, I just want an example. Okay. Gaming play. Yes. Playlist. I guess doubly linked list we also use in playlist. Where is the difference between in the playlist between doubly linked list and circular linked list? Because in playlist, I guess yesterday also we gave the example of playlist. When I told you about the practical example of this doubly linked list. Now, where is the difference? Yeah, it is playlist. Circular linked is operating system. Why is in operating system? Yeah, round robin CPU scheduling. Good. Good. Embedded system. May I know where in embedded system? Managing players in multiplayer games. Good. Gaming playlist. Okay, great. Good. So this is great. So fine. Good to see your answer. Simply saying a circular linked list is a linked list where the last node is pointing to the first node. Simple. I will give a very basic definition. Means the last node next is pointing to the head, isn't it? Like if we see the example here, the last nodes next, it is pointing to this head. So this becomes the circular linked list, right? It is a kind of, I can say this now, there is no ending list. There is no end to the list, isn't it? Because when there is no end, every node is starting and ending, is getting a reference from someone and is ending by giving a reference. So no node is pointing to null. In other words, I can say, isn't it? When no node is pointing to null, it means the list is circular. It is forming a kind of a circle. Now, as you see, you have given good examples. Let me take the example of this CPU scheduling. And there are so many scheduling algorithms. One among those scheduling algorithms is round robin. So may I know what is round robin scheduling? You might have studied in operating system. Very common scheduling algorithm. We have got so many scheduling algorithms, be it first come first serve, shortest job first, round robin algorithm, and other algorithms as well. Shortest next job. So many algorithms are there, and one among them is round robin algorithm. And how that round robin algorithm is related to this circular linked list? Which second point I have to explain? I not explained till now. We are in. May I know which second point you are pertaining to? Which second point you are saying? May I know? Okay, let it be. I don't get you. So I'm just saying this round robin algorithm, sir. No, I have not explained the algorithm yet. First, we are discussing circular linked list and its application. Like a common application that you people told me, it is CPU scheduling algorithm, and the scheduling algorithm is round robin. And you know what is round robin algorithm? Can anyone tell me? Just a quick recap of your algorithms. This scheduling algorithm. Yes. It assigned a fixed slice called a yes, good quantum process. See, it is simple, good. Because as I already told you, we have so many scheduling algorithms. Be it first come first serve, shortage job first, round robin, shortage job next, and other algorithms, right? They are simply used to time this. I can say like now this to manage the time sharing between processes, because we have got so many processes actually, right? Process one, process two, process three, and each process is given a kind of a time slot, right? Or I can say each process is utilizing some time to get processed by the CPU. So what we usually do, we give a specific time to the specific CPU time to each process. In this round robin algorithm, what we actually did, we give each process a specific, or I can say a fixed amount of CPU time, right? We call them as time quantums. You might be knowing that. So each process is given a fixed amount of CPU time called a time quantum. Like suppose if there are four processes and each process is given a time quantum of 5 units, and each process requires like suppose 10, 20, 30 or 40 units of time to get processed. So in this round robin algorithm, what we usually do, we give each process a fixed specific or fixed time quantum. Like suppose I give 5 time quantum to it, 5, then next 5 to 8, then next 5 to 8, then next 5 to 8. So after this fourth process, like na gets its time quantum means 5 units. Now what will happen? It will go back to the first process, then again second, third, fourth, again till their processing time reached. Once their processing time is completed, that process gets completed. Similarly, if this gets completed, if this gets completed, and finally this gets completed. So with this way, it is working in a circular manner, in a circular fashion. Circular linked list means first process get its time quantum, second process complete get its time quantum, process the process your job, whatever job you have. Third, fourth, after fourth again first, then second, third, till their completion time exceeds, till they reach their completion time. So after each process's time slice is over, the CPU moves to the next process in a queue-like manner, and that queue is a kind of a circular queue. After the last process, it will turn to the first one, and this continues in a circular manner until all processes are complete. So this is actually where we found this circular linked list useful, right? One more example is this playlist, but the playlist is what? It must be a repeated playlist, means you have played like 10 songs and you are saying they are repeated playlists. After 10 it will again play first, after 10 it will again play. So this is a kind of a circular loop, right? So there is no end to it. There is no last node dot null, last node dot next is not null, last node dot next is first. So this way we are actually doing the things in a circular manner. So there are other examples like you have given. So this is what is circular linked list. Yeah, it is preempt. I don't go into the deep into the details what is preemption, non-preemption. So it is simply an algorithm which makes use of time quantum. After that, whenever all the process, first process, second, third, and last process, then again CPU is given to the first process, then second, third, fourth, fifth, and so on. Then again last, then again first, till all processes get complete. So this way, actually, round robin algorithm is working. Okay, hope it is fine. Is it clear? Yes or no? You can take a break. Yes, tell me till now, is it fine? Then we will discuss this insertion algorithm after break. Just a quick message if things are clear. If you have any question, you can ask. Okay, we will go for a break and we will be back at 2015. Okay, good. Try to give answers, be attentive, be interactive so that more things will become clear. Okay, let us be back at after 10 minutes. Okay, welcome back. Yeah, are you there? Are you there? Yes or no? Okay, let us continue then. So we are discussing what? Circular linked list, right? Where the last node is pointing to the first. It is not like last dot next is not null. It is simply the first node. So that is a circular linked list. So how do we create a new node in a circular linked list? Or I can say we have to insert a new element into a circular linked list, right? So here, first what we will check, create a new node with given data that we want to insert. Simple. Like in the singly linked list, what we did, we were creating a simple node with a given data, like uh, node, node data, node next. Right? Similarly, here what we'll be doing, we'll be creating a new node. Then we'll check if the list is empty. If list is empty, what will the node that we have created will become the only node of the list, isn't it? So that is, we will be checking that. If head is null, again I am checking. If head is null, means the list is empty. So we will set, till now the head was pointing to null, so we'll set this head to the new node that we have created, means the new node that we have created, right? So we'll set this head to new node. And this node will now point to itself, means this is the only node now. If it was a node, it was head. Initially head was pointing to null, means nothing there. Now I am saying that head is now pointing to this new node, and this new node will point to itself, right? Means that is the only single node in the list. Fine, it will point to itself, means new node dot next is equivalent to her. Whatever it new node is next, it will point to this head. So it would be the only node in a circular linked list. So you have to check now. What if there is only one node in a circular linked list? For that, the condition is if node dot next is equivalent to high, is equivalent to head. If new node, yani ki first node's next is what? If first node's next is head, we say it is the only node in a circular linked list. Means the new node or the only node which we have in a linked list, it is pointing to itself. So we say it is the only node in a circular linked list. Otherwise, the list is empty. So we have to check, right? So what we did, simply, let me clear the drawings. We create a new node, fine, and that node will be holding a data that we want to insert in the node data part, right? And the node has this next pointer, node next, and that will be updated uh, to maintain this, in order to maintain this circular property of the list. What we did, so we have to write, like for example, if this is the node, right, that I have created, here is data, d means data, this was head. Initially it was not pointing to anything, now I have created this node, so head dot next will become this new node. In order to maintain a circular linked list property, what I have to do, I have to set the new node that I have created, it is next should point to head. So with this, the circular property is maintained. You have to keep it in mind. Now after that, we are checking what? We are checking whether the list is empty or not. So for that, what we'll be doing? We will be checking as per the algorithm. If this head, I can say if head is null. So what does this mean? If head is null, means there is no node, that I have checked over here also, right? In the very first step, if head is pointing to null, what does this mean? The list is empty, means the list has no node. Now, in order to insert a new node as the only node, what you will say? You will simply write this head will point to new node, and new node's next pointer will point to what? It will point to the head. Right? Simply new node dot text is equivalent to head. Now, what if list is not empty? At that time, what we have to do? So, if the list has got some nodes and we want to insert the node at the end, means without breaking the circular link in between, we want to insert the new node at the end. So the in circular linked list, the end of the circular linked list is defined how? The end of the circular this linked list is defined. For example, if you have a circular linked list, it is end is how we do define the end of a circular linked list. If there are so many nodes, this is it. I have this node. There is another one node. How do we define the end of the circular linked list? Yes, means whenever a node is pointing back to the head, we will say it is the last node of the, or I can say the end of the circular linked list. Whenever a node whose next is pointing to head, we will say that node is the end of the circular linked list. Keep it in mind. Whenever node's next is pointing to head, we will say it is the last node, or I can say the end of a circular linked list. So how do we find this last node, or I can say end of a circular link? It is simple. We will start with a temporary variable that we were doing, isn't it? Previously we were starting with a temp. So we will move this temp forward using temp is equivalent to temp dot next. So we will do it repeatedly until you will find that the last node where temp dot next is equivalent to what? If temp dot next is equivalent to head. Like previously in doubly linked list, you were checking if temp dot head is equivalent to null. You were saying that was the last node. Or temp dot next was equivalent to null. You were saying it was the second last node. So here what you will be checking? Temp dot next is equivalent to head. Simple. So when temp dot next is equivalent to head, you will say it is the last node. So by this we can check that we have reached the last node. After reaching the last node, what we have to do? We have to insert a new node. So I have created a new node in the first step. If we check over here, I have created a new node in the first step itself. Here, right? So now I have to do once this last node is found, I will update the next pointer to point to the new node. So simply this temp dot next, it was initially pointing to now head because it was the last node. So I will set this new node's pointer to head, means whatever node I have created here initially, I will set it as pointer to head. So when I will set it as pointer to head, what will happen? The temp dot next, it was initially pointing to head, so it will no longer point to head now. Now this new node will point to head. So this way the list will, and this temp dot next will point to the new node, point to new node. And then after that, this new node dot next will point to head. So with this, a circular relationship is maintained. So it will still remain a circular. So this is how do we insert a new node at the end of a circular linked list. I hope it is clear. Yes or no? Is it fine? Yeah, tell me. If we check diagrammatically as well, here it is. This is the new node and we want to insert this node at the end. So for that I have to check what? If node dot next is equal to null, or I can say temp I have created. Initially, if temp head dot next is null, so there is no node. So simply then I will insert this node itself. Then I am checking for the last node. So for that I am creating a temp variable. If temp dot next is equivalent to head, we will say this is the last node. So for here, this is the last node. So in order to append this node to it, so what I will do? I will set this temp dot next is equivalent to new node and new node dot next is equivalent to head. So with this way, I am inserting this node here and it will point to what? Now this will point to head. So this way we are actually inserting a new node. Any questions? Okay, fine. So this is the program. See, it is also simple. No rocket science in it. Same program. Create a node. If you check, see how easy it is. Only one program you have to understand, you have to logically get, things will become more clear. I am creating a node, class node data next, then constructor to pass this data, this dot node and this dot next and this dot node. After that, I am using a method to insert a new node at the end. So for that, I am checking if the list is empty. In order to check whether a list is empty or not, I am just checking if head is equal to null. So then list is empty and simply what I will do, I will make the new node as the first node. So head will simply become the new node and new node next will become the head in order to maintain a what circular link. Else node temp is equivalent to head. So if it is not the only node, if the list is not empty, then I have to create a temporary variable and I will put head in that temporary variable, right? Then while temp dot next is not equal to head, so it will loop until temp dot next is not equal to head. So when temp dot next is equivalent to head, so what does that mean? That means this last node is pointing to head. So when any node is pointing to head, that becomes the end of a circular list. So at that time, I will simply write temp is equivalent to temp dot next. So that becomes it. So after that, I have to insert a new node after last node. So for that, what I have to write? Temp dot next is equal to new node and new node dot next is equivalent to head. So with this, I am simply adding a new node. So this is for then displaying whatever we got, and this way we have run this program. If you have got any questions, you can ask till now. Yes, I will copy the program and we will check what will happen with it. It is simple, it is not that difficult. Let me remove it. Let me run this. Okay, I have not shared the screen. Let me share it. Okay, this is the program. Same program I have taken. I have copied the same program. If you check, here I am defining a node, right? Then here I am inserting a new node and checking at the same time whether the list is empty or not. Here, then I am inserting a new node at the end with this. Then this is the message. So simply the message is circular linked list with these nodes 10, 20, 34. Same example that we discussed. Okay, is it fine? Inserting once again. It is simple. Okay, let me explain. Using the program or the algorithm. You want me to explain it with the help of program or algorithm? I guess. Okay. Algorithm. Yes, program. Fine. See, whenever you have to insert a new node in a linked list, for that we have to create a node. So when we have to create a node, we have to define a class for that of type node. So there, actually we do these things. We are declaring data, it is data part and the node part. That we saw in the very basic lecture of linked lists. How do we create it? Right? We are two variables here. One is data and another one is the link part, reference part. So its type is int and its type is node. Then we are creating a this constructor. This also we discuss. And in constructor we are passing data and we are giving it with the help of this operator. This dot data is whatever data you have. This dot next is equal to null. It simply means the node that you are creating, it is pertaining to null. So I'm this only node, empty node with this data, any data, right? After that, I have to insert a new node, right? In order to insert a new node, I have to check whether the list is empty or not. If the list is empty, by inserting a new node, that node becomes the only node in the linked list. So I have to check whether the list is empty or not. How do we check whether the list is empty? Simply, if the head, the DMU at the railway station, if nothing is attached to that DMU, no coach is attached to that DMU, what does that mean? It means there is no coach attached to this DMU. It means this train is empty. No coach attached to it. So simply when I say head is equal to null and we say the list is empty and this head is equal to, see, if head is equal to null, what does this mean? This means the list is empty. And when list is empty, whatever node you have created, that will become the new node. So simply, if it is empty now, this head will point to what? It will simply point to new node that you have created, right? And what would be the new nodes next? In order to make it a circular linked list, this is a new node. In order to make this new node as a circular list, this new node next should be equivalent to what? Should be equivalent to head. So these are the two things. Simple. Head should point to head is equivalent to new node dot next, and new node dot next should equivalent to head. So in order to make it a circular link, else node temp is equivalent to head. If the list is not empty, then I have to create a temporary node that I already told. If there are so many nodes already in the list, so for that I have to create a temporary node, right? So why do we create a temporary node? In order to create a loop, in order to reach to the last node. So for that I am creating this temp node, and this temp node, in this temp node I am placing head. I am writing it equal to head. So for that I will now traverse the whole linked list till what? Till temp dot next. Till this temp dot next. Temp dot next, if temp dot next is equivalent to what? If it is equivalent to head, what does this mean? What if temp dot next is equal to null? कोई बताएगा? Can anyone tell me when temp dot next is equal to null? What does that mean? Yes. What does that mean when I say temp dot next is equal to null? Screen got freezed. Just a minute. My screen got freezed. Are you able to view the screen? I guess. Just a minute, screen got freezed actually. Zoom is there. Let me stop share for a while. Open to it. Yeah, am I audible? I'm not trying finding you where you are actually. I don't know what happened to it. Actually, screen got freezed. I'm not able to view the windows.
Sir, what was the issue, sir?
Okay, are you able to view my screen?
Sir, your screen is not visible, sir. Sir, your screen is not visible actually.
Why my presentation screen is not coming? Okay, are you able to view my screen?
No, sir, it is not visible actually. Sir, if you are facing an issue, can you please drop the session and rejoin back?
I don't know.
Yeah, now it is visible, sir.
I don't know what happened to it. Just a while, I will do one thing. Not able to find my presentation. Okay, I guess it is visible now, screen.
Yes, yes, sir, it is visible.
Okay, sorry for the disturbance. Actually, I don't know what happened to it.
That's okay, sir, no problem.
I'm not able to switch it now. Okay, so we're discussing what? This insertion, isn't it? So here we were creating the node, then we were just checking whether the node is null. If it is null, so it means the node that we have created, we have to insert it directly. So for that, what we have to do? Simply we'll say new node is equivalent to new node data. Right? Then after that, if the list is not empty, so for that I have to set a temporary variable. So initially I will be setting head into that temporary variable. Then this temp will go on, temp dot next, temp dot next, temp dot next, and so on. So after that, what we'll do? We will check until temp dot next is equivalent to what? Head. When temp dot x next becomes head. So what does that mean? That simply means that this is the last node in a circular linked list. So when this node temp is equivalent to head, it simply means we are at the last node of the circular link or end of the circular link. So for that, what I will be doing, I will be simply writing temp is equivalent to temp dot next. So after once I will find that this temp dot next is equivalent to head. So I came to conclusion that this is the last node, or I can say end of the linked list. So for that, what I will do, I will simply write now the new node which I have to insert. So for that, I will write temp dot next is equal to new node, means this temp which is the last node till now, its next will become the new node that I have created this. So this new node next will become what? It will become the head of the list. Means this new node dot next will become head. So with these two statements, we are actually doing what? We are actually inserting a new node into the list. So how do we display this result then? See, with this property, what will happen? Actually, this is maintaining the circular property. When we are writing this new node dot next is head, so it is actually a circular property. Here also, during the when the list was empty, here also we were writing new node dot next is equivalent to head. Here also we are writing new node dot next is equivalent to head. So it simply means what? It simply means here if we check this property and this property, both are same. So these are actually maintaining the circular link, the circular property of a linked list. So with this, we are actually doing what? We are creating a circular list. Then I am inserting these lists. So actually, I guess I have shown it. Okay, let me share this screen now. I hope this screen is now visible. The list, the screen which I was showing you initially when it got freezed. Is it visible? See here, same program. I have copied and pasted here. This, I guess I have explained it. Then method to insert a new node that I am doing here. First checking if the list is empty. If it is empty, the new node will become the only node of the list. If the list is not empty, so I have to traverse the whole list. So for that, what I have to do? I have to simply create a temporary variable, and I will check if temp dot next is equivalent to head. So that will become the last node. So after identifying that this is the last node, then I will be doing like this. Temp dot next will become a new node, and new node dot next will become a head. So that's it. When I run this program, it will simply create a circular linked list, and it will insert a new node in it, like 20, 30, 40. It will insert a new node into the linked list. So hope it is clear. If you have any questions, you can ask. Then we will go to the next part of the course. After that, we have deletion. Deletion is also simple. If we check here, deletion is again simple. For deletion, what we have to do? If you want to delete at the end, so simply you have to write. Initially, you have to check whether the list is empty or not. For that, again and again, we are repeating these steps. If head is equal to null, so we'll let me check the screen share first again. Okay. So again and again, we are checking it whether the list is empty. For that, I have to check if head is equal to null. If head is equal to null means there is no list, no node in the list, so list is empty. We'll print it and stop. Then we'll go if head dot next is equal to head. So what does this mean if head dot next is equal to head? Yes, can anyone? If head dot next is equal to head. Can anyone tell me what is this? If head dot next is equal to head. Yes, good. When it is the first and the last node, means if head dot next is equal to head, whenever you have got only one node in the list, this. So if it is next is pointing to head itself, so it is the only node in the list, first and the last node. Good. So if head dot next is equivalent to head, in a circular linked list, we know it that if the node next points to itself, then it means it is the only node in the linked list. To delete it, how do we delete it? We will simply set head is equivalent to null. In order to delete this only node, what we'll do? We'll see if it is the only node in the list, right? It is head. This head is pointing to this, and it is next is pointing to here. So in order to delete this node, what we will do? We will set this head is equal to null, means we will point it to nothing. When we will point it to nothing, this will get automatically removed. So this is how do we delete a single node in a linked list. Then we will stop, and that is it. Now what if there are so many nodes like this in a linked list? What we will do? Then we will initialize a pointer again, same pointer temp, right, like we did. So we'll set node temp is equivalent to head, right, like here temp is equivalent to head and node previous is equal to null. So we'll initialize when node temp is equivalent to head and it is previous is null, right. So this temp will be used to traverse the list, and with the help of this temp, what we'll do, we usually try to find the last node or last but one, right. If it was doubly circular linked list, we were searching for last but one, but in this circular linked list, we will be trying to find the last node, end of the list. So for that, we'll be using this temp variable, and this previous will be used for what? Previous will be used to keep track of the node before the one that the temp is going to point. Means if temp is pointing to 10, this previous will point to what? 9. So it will keep track of the node before the temp is pointing to. See, now we'll see why it is needed. It is needed because we can move only in one direction in a singly linked list. So we have to keep track of the previous as well. So that is why we are just saying node previous is equal to null. In order to move forward in a singly linked list, we use this previous is equal to null as well. Now we'll traverse to the last node. How do we traverse to the last node? Simple. Temp dot next is not equal to head. If temp dot next is head, so what does this mean? Temp dot next is head. It means it is the last node. So we'll loop until temp dot next is not equal to head. When temp dot next is not equal to head, means no last node. Once we reach temp dot next is equivalent to head, so we will say that it is the last node. As we know, it is a circular list. So what does this mean? This last node should point to the head. So we will loop until temp dot next is equivalent to head. Meaning the temp that we created, temporary variable, temporary node, it is the currently last node. Right? So this previous will do what? Set previous is equal to null. What will it do? Or set previous is equivalent to temp. Set temp is equivalent to temp dot next. So this set previous is equivalent to temp and set previous is equivalent to temp dot next. So what they will actually do? This previous is equivalent to temp, it will simply keep the references of the previous node. Simple. When previous is equal to temp, it means it is the previous node. It will keep track of the reference. When temp is equivalent to temp dot next, with this we are moving forward. So inside the loop, what we are doing? We are keeping track of the previous node by writing previous is equal to temp, and when we have to move forward a step ahead, then at that time we will write temp is equivalent to temp dot next. Right. So at the end of this loop, after this loop, temp is pointing to last node and previous is pointing to second last node. So after that, what we will set? Simple. Once we have found that temp is pointing to last node and previous is pointing to last but one, second last, then we will set previous dot next is equivalent to head. Means whatever was z, it was previous, it was next. Now I will simply write previous dot next. It will now point to head. See, why do we create this previous? Simply for what purpose we created it previous? Keep track of the previous node. Because then only if we have a keep track of this previous node, then only we can say that this previous will point to head. Otherwise, if it was not a circular link, then there was no need to keep track of this previous. Because once we remove this node, we should be able to know the address of this node, the designation of this node. Only then we can say that this node will point to head. So in order to point this node to head, we have to set it as previous. Right? So that is why we have created a previous variable over here to keep track of the what? Previous node, to keep reference of the previous node. So this way, what we are doing, we are actually this, when we say previous dot next is equivalent to head, we are removing this last node. Is it clear? Yes or no? See, now I can tell you like this also. For example, there is now, I can create a scenario. What if the list is empty? What action should you take? If the list is empty, you want to delete an item, delete a node in the list. What message should you print? Simply do nothing or print message list is empty. Isn't it? Now, what if I have only one node list? What will I do? What will I do for this? If I have only a one node list. Can anyone? Only one node list I have. So I have to delete that node itself. So for that, what I am doing? I am simply writing head is good. Head is equal to null. Right? And what if I have more than two or more nodes? What action should I take? Yes. What action should I take? Simply I will traverse to last. I will traverse to last and right. How do I traverse to last? If temp dot next is what? Yes, if temp dot next is null, it means it is the last node. Then I have to update. How do I update? Simply previous dot. Can anyone tell me? Previous dot next is equivalent to what? Can anyone write? Can anyone write? Previous dot next is equivalent to? No, previous dot next should not be temp. If you go to the algorithm, at the end, when I am deleting the node, see at the last line, previous dot next should point to head. Yes, previous dot next should point to head. So when this points to head, it means the list is circular list. So this is actually the flow, or I can say the summary scenario. You can take a screenshot of it. This is, if you understood it, that is the story of circular link, this linked list. How do we delete? And you know how to check the list is empty. If head dot next is equivalent to, or I can say head is equivalent to null. Head is equal to null is when the list is containing, see actually empty list is this, head is equal to null. If head dot next is null, I don't know whether I have written like that. Head dot next is equal to null, it is one node list. And for that, actually, I am writing then, if when I delete it, I am then writing head is equal to null. Actually, I have explained it, but not written. So it is, how do we delete a node at the end of a circular linked list? So with this, this, if you want to take a screenshot of it, you can take, but I guess I have written it at a wrong place. But if you got it, then it is fine. Okay, so with this, we completed linked lists. Tomorrow we have to check, yes, stacks. Yeah, head dot next is equal to, actually, na, at that time I was just explaining it, not writing it. Okay, so tomorrow we'll be explaining stacks. Let us give an introduction of stacks. I guess we gave the introduction of stacks in the previous lecture when we were discussing data structures, right? No, it is, I guess, on Monday. Tomorrow is holiday. Yes, Saturday, Sunday is off. So on Monday, coming Monday, we'll be explaining it. Okay. Before starting this stacks, can anyone tell me the practical application of stack? Then we'll go to stack on Monday. We discussed few of these applications already. Railway ticket, railway ticket, railway ticket stack, evaluating, yes, expressions. Can you give a clear answer on this railway ticket? Yeah, we'll be doing this. You mentioned it, postfix, infix, prefix. We'll be explaining it. We'll do a 1 hour session on these evaluations as well. How do we convert prefix, postfix, and infix? And it is a common question asked in competitive exams. You'll be given these graphs, or I can say nodes. Then you'll be asked to perform infix traversal in order, or we can say in order traversal kind of things. So then we have got those expressions, infix, prefix, and postfix expression. Actually, they are making use of stack. Good. Storing books on the shelves. That is also fine. Stack of pallets in a marriage. Yes. I was just asking about this railway. Someone give the example of railways. I'm not getting it. How it is actually using that. If you can please illustrate that. It's for Q. Okay, it is that is for Q. Right. That's why I got confused. How is used? I thought you might be having considering that. Now I was thinking in mind about that reservation kind of thing online. How seats are being allotted, but I didn't synchronize it. That is why I asked you. Okay, thank you for clearing it by yourself. Yes. Any other? See, there are so many applications. If we see the traversals in graph, DFS, BFS, or in backtracking algorithms, they are also, or memory management. If you remember yesterday, I told you the recurrence relation, or I can say the this Fibonacci series factorial. How do we use that? There also so many applications are there. We'll be explaining almost. We'll try to explain like common examples that are making use of these stacks. Right? And I guess in compilers as well, we are making use of stack. Then we try to deal with those parentheses kind of things or syntax analyzers. Okay, let it be. We'll discuss all these things. If you have any questions, you can ask. Then we'll explain this stack queue in the next session, along with algorithms and programs. Stack of bangles, good. Stack of books arranged in laboratory, that is also fine. Stack of pallets, yes, they are arranged in a stack. The stacks, first in, first out. Expression evaluation, good. Okay, if you have any questions, you can ask. I hope today's session you got the concept of this. circular linked list and doubly linked lists. If you have questions, you can ask, or else we can wind up the session. Thank you so much for joining the session. If you have got any questions, you can ask. Okay, shall we wind up the session?
Yeah, yes, sir, we can wind up.
Okay, fine. Thank you so much.
Yeah, thank you, sir. So as tomorrow and day after tomorrow, we don't have a session. We are meeting again on Monday. So students, as you all know, Saturday and Sunday, we don't have our classes. Okay. So we'll join again on Monday. Thank you all for joining. Good night.
Okay, thank you so much.
Thank you, sir.